Okay, we're in section 48. What's the expectation? That you read the contents, you make some attempt to understand the examples that are presented to you, and then you start working on the exercises. My name is Ron Bannon. This is a draft version of my adaptation of the Webster Wells Advanced Course in Algebra, which dates back to 1904. The PDF document that you're viewing here is being made available to the Prism Mathematics Project. All right, so I'm going to point out that I know there's other people watching these videos besides people involved in the Prism Mathematics Project. And if you're a student or teacher interested in the document, email me. It's not published yet, but it will be published at a later date. And my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right, let's scroll through and see what the topic's going to be. And this topic over here is complex numbers. All right, so, I'm going to say read through it. And certainly I know it's difficult, but we'd like you to read through that, all right, and try to make sense out of it. Now, certainly when I get to the examples, the understanding is that you've looked through this material. And Wells is very thorough, there's no doubt about it. For some students, it's a little bit too wordy. And so a lot of students are not used to reading and understanding what they've read. They're more or less want to be talked through the material. And that's what I do with the examples. I kind of, talk through the material, all right? So I give an overview, a shorter version of what Wells is talking about, not as complete, and I go through that, all right? So my goal over here is, you can read through that as well, my shortened version of it, but I got to be honest with you, when I'm looking at this stuff over here, this is a major step up from what you would see in an algebra class nowadays. You just wouldn't see this stuff. Now, granted, when I write the solution key up for you, you can look at that, of course. I'm going to attack the problem a little bit differently, to be honest with you. So I'm going to look at this over here, and I'm going to write down what I'm seeing. I'm seeing this over here, and I'll write this down for you. It's going to be 7 minus 6i root 2. And what I'm going to do, I'm making an assumption that this is going to be written down as a complex number in the form a plus bi. I'm going to use an uppercase letter, though. A plus, well, let me make it minus, because I notice there's a minus sign over there. I'm going to say I make an assumption this over here. All right? I'm assuming it can be written that way. Now, what I don't know the a and b. So what I'm going to do is I'm going to look at this and look at this. I'm going to square both sides. And what would you get? You would get 7 minus 6i root 2 equals, well, this is going to be a squared. And for students who have a tough time with this, I'm going to write down what I'm doing. A minus bi squared means a minus bi, a minus bi. Let me multiply that out for you. You get a squared minus abi minus abi plus b squared I squared. And I squared you should know to be minus 1. So what are you going to get? A squared minus b squared. And then what do you get? Well, you get minus 2 abi. I'll write that down for you. All right, let's take a look. I'm going to write it a little differently. I'll tell you why, because I don't like the a squared minus b squared. It's just too difficult. Let's write this down instead. Square root of a. No, I'm not going to do a minus. Let's put the minus sign down. Minus the square root of b, I. Well, I'm still going to square both sides. 7 minus 6i root 2. This will be a. I just did it before, by the way, but now these are square roots, so it's going to be a, not a squared, minus b, minus 2 root ab I. All right, so you notice I change, I update. I said it looked too difficult to do, and now someone says, what are you going to do now? I'm going to equate. I say the 7 is equal to this thing over here. Let me write that down for you. And see if I can do the best job. So 7 would equal A minus B. All right? And now I'm going to equate this thing here with this thing over here. And what do you get there? You're going to get minus 6I root 2 is equal to minus 2 root AB I. All right, I got two equations now, two unknowns, by the way. All right, the first equation was pretty easy. The second equation looks really nasty to me. But yeah, I'm gonna divide both sides by, I'll write it down for you. I can divide both sides by minus 2I. And what do you get there? Well, you get 3 root 2 equals root AB. Well, I'm going to square both sides. I'll write that down for you. And what would you get? You get 9 times 2, which is 18, equals AB. Now, what I'm going to do now, I'm going to take this. I'm manipulating. I know that if this is crazy. I'd rather do this over here. This is what Wells is doing. Now I'm going to take a look at this. This makes it pretty difficult, right? So I'm going to solve this thing for B. What would B be? It would be equal to 18 over A. I'm going to take this. I'm going to plug it in here now. Let's write that down. 7 equals A minus 18 over A. I'm going to multiply both sides by A. It's work. 7A. A squared minus 18. A squared minus 7A minus 18 equals 0. 0, A, it's a lot of work though, I'll get there, and A, I can say 2 and 9. A could be 2, or A could be 9. Now if that's true, what would B be? B would be, I'm looking at this over here, it would be 18 divided by 2, which is 9. And if A is 9, what would B be? It would be 2. Now someone says, why do I need that? Well, I'm up here. I want to point out this is a principal root. Now, what does that mean? I'm looking for a solution that would give me the principal root. And let's take a look at that. And I'm going to say the A, let's write this down. Let's take a look, is 9. I'll write this over here. Minus, let's keep going, root 2I. All right. Root of 9 is 3 minus root 2I. All right. Right over here. All right. You know, I think I might be repeating myself. Let me just take a look. I think I've done this one already. No, I haven't, so I'll keep going forward. I thought I did it. So let me take a look. I was just looking over my notes, seeing if I'd done this one before. It's deja vu all over again. All right, so, and these are not easy. I realize that they're not easy. All right, so let me see if I've done okay. And I think I did okay in that one over there. Let's look at this one over here. And boy, it really does look like deja vu to me. So I'm going to write it down for you. And what I mean by deja vu is I've seen them over and over again. And maybe I'm just dreaming I've seen it over and over again. And this one's got a slight problem to it. And I'm going to factor out the minus 1 on this guy. So let me put this down for you. So minus 1 times 35, right, minus 12 root 6. It's a complex number, and I'm seeing I. Why is that? The square root of minus 1 is I. And then I see this root problem, which is 35 minus 12 root 6. This is actually easy for me to do. What I mean by that, I'm going to look at it. I'll write this down for you. And let me put this down. And I'm concentrating this section over here. And before I do that, I want to go back and make sure I did a good job in this one over here. And I got to be careful here. All right, let me keep going. I'll put this one over here. You know what? I'll write it down here. So I'm going to say the root of 35 minus 12 root 6 is going to be the root of A minus the root of B. I'm going to square both sides. You're going to get A plus B minus 2 root AB. Hopefully you get better doing the multiplication. I'm going to say A plus B is 35. I'm equating coefficients. And I'm going to say minus 12 root 6 is minus 2 root AB. I'm doing the same thing over and over again. I'm going to divide both sides by minus 2. I get 6 root 6 equals root AB. I'm going to square both sides. You get 36 times 6. Let me write that down for you. 36 times 6. That's 180 and 36. And that's going to be 216. Equals AB. I'm doing the same thing I did before. I'm going to solve for B, and B is going to be 216 over A. And then I'll substitute in here. See what I get. So you get A. B is 216 over A equals 35. I'm going to multiply both sides by A. So almost like a robot doing these things. Plus 216 equals 35A. Well, this is going to be A squared minus 35A plus 216 equals 0. A and A. And again, I got a good deal of faith it's going to work, by the way. Sometimes it doesn't, by the way. Sometimes you're in a nightmare. You can't get out of it. So 216, which is, let's see what that would be. I got to write that down, right? So I'm 216. And I know that 216 came from something pretty simple. And I'm going to say it was 36 and 6, right? Hope you remember that. But that's not going to give me 35. So I got to search around for something else. And I'm just going to write the factors down. Now, not all of them, but some of them. 4 and 9 and 3 and 2. I'm going to play around with that. And, something I noticed right away, I noticed that 9 and 3 is 27, and 4 and 2 is 8. And if I added those two numbers together, I would get 35. So I think I got it. I'm going to put down minus 27, minus 8. All right, let me keep going. What's A? A is 27. What's A over here? I should put an or down. Let me put that down for you. These are tough, by the way. 8. And I'm looking at this over here. And I think I can do that. I just did it before, right? So 8 would be 27. And this would be B is equal to 8. So I think I'm ready. Now, when I say I'm ready, I want to tell you what I'm looking at. I'm looking at this business over here. 35 minus, I want to make sure 12 root 6. And this will equal, I said, it's going to be equal to what? Root A minus root B, right? Now, by the way, I hope you're looking at this. Now, let me just discuss it for you, some number sense over here. The root of 6 is between 2 and 3. But certainly closer. Well, maybe you don't see that. So let me put this over here. And if you did that, I'll write this over here. And I hope you realize that if I do 35 squared, and I did 12 root 6 squared, right? 35 times 35, and this would be 144 times 6. You get the idea what I'm doing over here? Now again, I'm hoping that you're seeing this, but if not, let's go through it. What do you get over here? 600, and then you get 240, and then you get 24. Now let me do the 35 squared for you. 5 times 5 is 25. 5 times 3 is 15, 17. 3 times 5 is 15. 3 times 3 is 9, and that's 10. 7 and 5 is 12. I hope you realize that 35 squared is greater than 12 root 6 squared. So what am I saying is that this number here is positive. All right, let me get my eraser out. Again, if you saw that, don't do that work I just did. Not worth it. So I gotta be careful. It's a positive number, principal root, right? So what do I got? I look at it, and I'm gonna say it can't be this, because that would be a negative number, right? Let me erase this. So it's gotta be this one. I'm going to write it down a little better for you. This would be 3 root 3s minus 2 root 2s. Now let's not forget what I have in front of it, an I. So I'm going to write this over here, I times, let's go back over here, 3 root 3s minus 2 root 2. I'm going to say it's my answer. All right, now if you write a complex number, it would be 0 plus 3 root 3 minus 2 root 2 I. Let's look at the key, see how we did. And I see that right over here. All right, that's good news. All right. Ooh, this is good news. We had 2 questions, we did them. And what are we going to do now? We are going to talk about what your responsibilities are. Doing the exercises. Yeah, it's unnesting things. Your denest, extract, denest, 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 denest. Well, all denesting, right? See that? Denest, extract, denest. I put all the work down for you. Sage, what's Sage? It's a computer algebra system. CAS for short, open source. This is the website. You can download the application or use the interactive web-based application. Look at the code. My goal here, though, is not you guys looking at code so much, but looking at what Wells is asking you to do and try to do it by hand, with some exceptions, by the way. But if you see any errors, I would love to hear from you. And that's my address, B as in boy, the @ symbol, NNON.US. And we would love to hear from you. Thank you.